I'm Anil Kumar, and in this video we'll analyze the critical number, find the critical points, and then check do we have a local maximum or minimum at these critical numbers or not, right? So the question here is determine critical points for f of x equals to x squared minus 1 to the power of 1 over 3. Explain if the local maximum or minimum exists at these points or not. So whenever we say critical points, we are interested in both x and y value. If I say critical number, we are interested only in the x value. Okay, let's begin by finding the derivative of the given function. Function is x squared minus 1 to the power of 1 over 3. So the derivative for this function will be 1 over 3 times x squared minus 1 to the power of 1 over 3 minus 1, which is minus 2 over 3, times derivative of inside function, which is 2x. Now we can write this as 2x over 3 times we have x squared minus 1 to the power of 2 over 3, right? Now here we have a couple of critical points. Now critical points are when f dash x is equals to 0 or when f dash x is undefined, right? So these are the points where we have critical number, right? So these are the things. So it is 0 at x equals to 0, it is 0, right? So at x equals to 0, it is 0, and at x equals to plus minus 1, it will be undefined, right? So we have three critical numbers, right? So we can write the critical numbers are, so we'll write critical numbers are at x equals to 0, plus and minus 1. So there are three critical numbers. We can find the value of the function at these critical numbers. So we have f of 0 equals to, if I write 0 here, I will get 1 to the power minus, so I get 0 minus 1 to the power of 1 over 3, which is minus 1, right? And f of plus 1 and minus 1 will give me plus or minus 1 whole square minus 1 to the power of 1 over 3, which is 0, right? So when we say critical points, right, then I want to write this here as, then points will be, let me write critical points. In that case, we want to write both x and y value, right? So the values are 0 minus 1, and then we have 1 0, and we have minus 1 0. So these are three different critical points. Okay, so I hope from here it's very clear what is the difference between critical number and critical points. Now let us explain local maximum minimum at these critical points. For that, what we need to do is to analyze intervals between these critical points. So the intervals which we have here will be from minus infinity to minus 1, then from 1 to 0, and then from 0 to 1, right? So this is, well, this is plus 1, okay. So what have I written? It was correct, I'm sorry. So 0, these are the 3x values, that's correct, okay, anyway. So these are the points, and the test points could be minus 2. Here we could take minus half. Here we could take half. And then we could take a value 2. Now the function for us is right there, which we are going to analyze. And this is actually the derivative of the function, right? So we are analyzing derivative of the function, whose equation is given to you as 2x over something like this. Now in this, denominator is always positive, right? This is square. So denominator is positive, right? So if I take minus 2, it is going to be negative. So minus will give me negative. Again, minus will give me negative here, right? Plus will give me positive, and this plus will also give me positive, right? In fact, what you notice here is that always denominator is always positive. Right? So this part, what I'm trying to say is this part is always positive, right? For any value because of this square here, right? But the numerator, 2x, x value is negative, numerator is negative. Therefore, the derivative is also negative, right? So if it is negative, then what happens to the function? Let us see what happens to the function. Negative derivative means that the tangent is kind of like this, right? The graph is going down. Negative means the graph of the function is going down. Do you see? Going down. Positive means going up and going up, right? So from here you can see that we do have local minimum at one point, right? So local minimum is there. But at these 2 points, there's neither, right? Since going down and down, so neither. Here also it goes up and up, so it's neither. Do you see that? So local maximum and minimum only occurs at the critical numbers where the sign of the derivative changes from negative to positive or from positive to negative, right? In this particular case, what we find is that we do have a local minimum at x equals to 0, right? But at plus minus 1, it is neither, right? So that is how the function is. So we can write down our answer, and that is, the answer is that we have local minimum at the point where x value is 0. So x is 0, y value is minus 1, right? So for the function when x is 0, in that case it is minus 1. So that is, and neither at the other two critical points, which are minus 1, 0 and plus 1, 0, right? So at other critical points it is neither, right? So that is how you would answer this question. I hope that helps. Thank you.